Okay, the next topic that we're going to be working with is a topic called implicit differentiation. And we're going to use a lot of the things that we work with already, but we need to look at some things that are a little bit different. First of all, let's talk about some vocabulary. Functions can be represented explicitly or implicitly. For example, the function y equals 3x squared minus 5, we would call that an explicit equation or function definition, where y is explicitly defined as a function of x. When we say explicit, we mean very clearly we can see what y is. You give a value for x, you substitute a value for x, and then you square it, multiply it by 3, subtract 5 from that, and that is the value for y. Well, not all functions or not all graphs can be written in an explicit form. So take, for example, x squared plus y squared is 1. Well, x squared plus y squared is 1. If you notice, or if you recall, that is the definition for a circle of radius 1 centered at the origin. And its graph would look something like you see there. We can solve for y there. This is an example of an implicitly defined function. So what does an implicitly defined function look like? Your x's and your y's are all together. They're all mixed up. You don't have y equals something as a function of x. X's and y's are multiplied together, added together, etc. That is what we call an implicit definition. Now, if you look at it, one thing that bothers me about this is that we do know that a function has to pass the vertical line test. And this circle is not a function per se because it doesn't pass the vertical line test. So we're using the word function as if we would use the word equation in this particular instance. So whether we say an explicitly defined equation or an explicit equation or an implicit equation, implicitly defined function, don't get hung up on that, on the word function in that case. Now you might recall that we can, even on our graphing calculators, we can't put the circle function x squared plus y squared equals 1 into it. We have to, excuse me, we have to go to the y equals menu on the calculator. The calculator, and we have to type in a function or an expression that has only x values in it. And what that is saying is that all of the expressions or graphs that you can create on the graphing calculator are all explicitly defined. For example, what we would have to do to graph this circle in this case is to subtract x squared from both sides. Then we would take the square root of both sides and we would have to make it plus or minus. So this particular function, x squared plus y squared equals 1, or this particular graph, it could be represented explicitly if we use two different equations. Y equals square root of 1 minus x squared and y equals negative square root of 1 minus x squared. And I'm just going to go quickly and show you how you would do that on the calculator. So we go to y equals, and we have square root of 1 minus x squared, close paren, and if we went over and graphed that, we would see this, it doesn't look like a semicircle, but that actually is a semicircle. And we would have to go in and put in the next one, which would be negative square root of 1 minus x squared, and go ahead and graph that, and we would see the two parts of the circle. Now actually, when you're doing a circle, it's best that you zoom square, which is 5, and you get a little bit better graph. And if we were to change the window size, it would be even better. And so I changed to -5 to 5 for x, -5 to 5 for y, and then I zoom square.